In 1997 AB 85, we also have a calculator question, and it says that if the derivative of f is given by f prime equals e to the x minus 3x squared, at which of the following values of x does f have a relative maximum value? Now what you have to watch out for here is that what you're given is not the original function. What you're given is the derivative. So that's a big difference there. Since we have the derivative, if we want to find a relative maximum value, that will occur when, or f of x has a relative maximum when f prime of x changes from positive to negative. Since we're already given the first derivative, f prime of x, which is e to the x minus 3x squared, then all we need to do is find the place at which that graph changes from positive to negative. So I show the function here, e to the x minus 3x squared. I'm going to zoom, standard, graph the function. Where does it change from positive to negative? It changes from positive to negative only around this value, around x is equal to 1. You can see that's the red dot there. At the green dot, at the first green dot on the left, the derivative changes from negative to positive, so that would show up as a minimum on the original function. And then we have another green dot, which is also a change from negative to positive, so that would also show up as a minimum on the original function. And so only the red dot would be a maximum there, a relative maximum. And so we need to find out what that x value is. So in this case, what we're looking for is actually a zero of the first derivative function. And so I do second, calc, number 2, which is a 0. I can start the left bound at around 0 and the right bound at around 3, and then guess, and it finds the 0 at 0.91. And so the answer would be C in this case. So what made this problem difficult is that you're actually working with the first derivative. You have to read that very carefully. You're working with the first derivative here, that you're given the first derivative, and all you need to find out is where the first derivative changes from positive to negative, find that x value, and in the original function f, there would be a relative maximum at that point. And that's it for this problem.